Inventory management focuses on determining when inventory should be replenished and how much should be ordered to balance customer service, operational efficiency, and inventory investment. Two primary replenishment approaches are order point systems and periodic review systems. Order point systems continuously monitor inventory levels and trigger replenishment whenever inventory reaches a predetermined reorder point. Because replenishment is initiated by actual inventory consumption, these systems exhibit pull characteristics. Periodic review systems evaluate inventory at scheduled intervals and place orders based on current stock levels and future requirements. These systems are generally forecast-driven and display push characteristics. Selecting the appropriate approach depends on demand patterns, inventory value, operational complexity, and service requirements. Organizations utilize both push and pull replenishment methods depending on product characteristics and supply chain strategies. Push methods rely on forecasts, production schedules, and planning systems, such as material requirements planning (MRP), to initiate replenishment before actual demand occurs. Pull methods replenish inventory based on actual consumption or customer demand signals. Examples of order point triggers include reaching a specified inventory level, consumption of a Kanban container, depletion of safety stock, or the occurrence of customer orders. Effective replenishment systems balance inventory availability with investment levels and support organizational goals. Hybrid approaches often combine push planning with pull execution to improve responsiveness while maintaining long-term planning visibility. Inventory planners use various techniques to determine appropriate inventory levels while considering service objectives, cost constraints, lead times, demand variability, and operational limitations. Dynamic inventory techniques continuously adjust replenishment parameters based on changing demand and supply conditions. Examples include MRP-driven planning, demand-driven replenishment systems, and adaptive forecasting methods. Fixed techniques establish predetermined inventory parameters that remain relatively stable over time. Common examples include fixed reorder points, fixed order quantities, and periodic review systems. The choice between dynamic and fixed methods depends on demand volatility, planning complexity, data availability, and business requirements. Effective inventory policies ensure adequate product availability while minimizing total inventory-related costs. Economic order quantity (EOQ) is a widely used inventory model that identifies the order quantity, minimizing the combined costs of ordering and carrying inventory. EOQ provides a theoretical foundation for replenishment decisions and helps planners evaluate trade-offs between order frequency and inventory investment. While EOQ establishes an optimal order quantity under specific assumptions, practical constraints often require modifications. Organizations may apply order modifiers such as minimum order quantities, maximum order quantities, supplier packaging requirements, transportation constraints, economic shipment sizes, or production batch limitations. These constraints ensure replenishment decisions remain operationally feasible while balancing inventory efficiency, supplier requirements, and service objectives throughout the supply chain. Lot sizing techniques determine the quantities ordered or produced during replenishment cycles. Fixed order quantity (FOQ) methods replenish inventory using predetermined quantities regardless of demand variations, while lot-for-lot (L4L) techniques generate orders that exactly match net requirements. Other methods include period order quantity (POQ), least unit cost (LUC), and least total cost (LTC) approaches. Manufacturing environments influence the suitability of these techniques. High-volume, repetitive manufacturing environments often benefit from EOQ-based approaches, while make-to-order and engineer-to-order environments may favor lot-for-lot replenishment due to demand variability and customization requirements. Appropriate lot sizing decisions support efficient inventory management while aligning with production capabilities and business objectives. Safety stock plays a critical role in protecting organizations from uncertainty in demand, supply, and lead times. Safety stock acts as a buffer that reduces the risk of stockouts and service disruptions when actual conditions differ from expectations. Organizations determine safety stock levels using statistical methods based on demand variability and service level targets, time period methods based on expected consumption during a specified period, or fixed quantity approaches established through management policy. Days of supply DOS. Calculations help planners evaluate inventory coverage relative to anticipated demand. Safety stock decisions must balance inventory carrying costs against customer service objectives. Properly managed safety stock improves service reliability while minimizing unnecessary inventory investment. Safety lead time provides an additional mechanism for reducing uncertainty by advancing replenishment timing rather than increasing inventory quantities. By ordering materials earlier than normally required, organizations create additional protection against supplier delays and lead time variability. Unlike safety stock, safety lead time only temporarily increases inventory levels and may provide a more efficient solution in certain situations. Inventory management also extends to maintenance, repair, and overhaul (MRO) inventories, which support equipment reliability and operational continuity. Special handling requirements must be considered for regulated materials, hazardous substances, temperature-sensitive products, and controlled inventory. Compliance with environmental regulations, material handling standards, personal protective equipment, PPE requirements, and workplace safety protocols ensures inventory is managed responsibly while protecting employees, customers, and the environment. Effective inventory management integrates replenishment strategies, lot sizing techniques, safety mechanisms, and operational controls into a coordinated system that supports organizational goals. Inventory professionals must continuously monitor performance, evaluate inventory policies, and adjust planning parameters as conditions change. Factors such as customer service expectations, demand variability, supplier performance, production constraints, regulatory requirements, and sustainability objectives influence inventory decisions. By applying appropriate replenishment methods, maintaining optimal inventory levels, managing uncertainty through safety stock and lead time strategies, and ensuring compliance with handling requirements, organizations can improve inventory performance, enhance customer satisfaction, reduce costs, and strengthen supply chain resilience. Inventory management, therefore, remains a foundational capability that supports both operational excellence and long-term business success.